All right, so this is number 28 out of section 4.5. Here they ask us to graph on the same graph two different sine functions. We can see here that this is the parent function, and then we have a transformation of the parent function. So moving right along with this problem, I'm using my tool here to keep me honest as far as how the problem is going to go. Now with sine of x, I will get to that in a second, but I'm going to go ahead and just kind of analyze g of x using my tool here. Now g of x is equal to sine of x over 3. Well, to use my tool, I need to first identify if I have an or my amplitude is. In this case, since I don't see it, that means that it's just 1. And then I need to see if I'm adding or subtracting anything to my entire trig function here. Okay? And in this case, I am not. Okay, so as far as filling out this section here, I now know that sine of x over 3, okay, will have the same y values as the parent function, because the only things that can affect the parent function are the amplitude and the d, which in this case is 0. And again, we're just thinking of it as plus 0 here, where anything being added to the function is called d. So if I fill them in, I just need to now say, well, I'm finding sine. Sine of 0 I know to be 0. Sine of pi over 2 I know to be 1. Sine of pi, and again I'm just using the values from the unit circle, sine of pi is 0. Sine of 3 pi over 2 is -1, and then I come around to 0. Now since I don't have to do any transformations to it, I'm going to go ahead and just put my y values over in the y value column here. And in this particular case, I know that's going to be true for both the parent function and the transformation, or f of x and g of x. Now, to find the new critical values, or the x values, for my function, what I'm going to need to do is I'm going to need to go ahead and take the input of my trig function, x over 3, and I need to figure out how I can transform that back to the input of my parent function. So I take x over 3, and I can see, and hopefully you can too, that what I need to do is multiply x over 3 times 3, and then I will get back to x. So that's what I'm going to put over here. That for every one of my special angles here, they're now going to be changed by multiplying them times 3. Okay. And if I go through, now I'm going to have my new x values, and I have 0, 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. Okay. So now looking at my graph here, I can see that if I'm going to run out of room if I don't make each one of these about pi. So I'm going to go ahead and just do that. Make this pi, then this would be 2 pi, 3 pi, and so on and so forth, up to 4, 5, 6, 7 pi. And I can see that I'll be able to fit everything in now. And now in the problem, they said to do it for 2 full periods. So I'm going to go ahead and just label a couple points here so that I can -5 pi and -7 pi, so that I can draw out a couple periods. And we'll get to that in a second. Now, for the unit circle, I'm just going to go ahead and use my special angles for the unit circle, and I'm sorry, that's for the parent function. The parent function is related to the unit circle. And so what I'm going to use is I'm going to use these x values and then the y values, since we saw that the y values did not change from f of x to g of x. So in this case, I have an x value of 0 and I come over here to my y value, and in fact, I can just use them here as well. This is my x, and this is my y values. So my x value is 0, and my y value is 0. Okay. Now I come to pi over 2, so halfway in between 0 and pi, and I'm up at 1. Then I come down again to 0 when I get to pi. Then when I get to negative 3 pi over 2, I'm at negative 1. And when I get to 2 pi, I'm back at 1. And that is one full cycle. One cycle of the function here. And since it has a frequency of 1, and I go ahead and connect my lines here, since this has a frequency of 1, okay, there's a coefficient of 1 in front of the x here, I know that that is also one period. Okay. I can also calculate the period by simply noting that this goes through one full cycle and it takes it 2 pi radians to do it. Okay. So that's one period, and I can go ahead and draw the second period now. Now I can draw the second period a couple different ways. I'm going to go ahead and start, and if I go from 0 back to 2 pi here, then I know that if I start right here, since each cycle takes 2 pi, I will finish up one full cycle, okay, by the time I get back to 0. And I'm just going to use the exact same y value. So I start with 0, then I go over pi over 2 and up to 1. Then I go over pi over 2 more and go down to 0. Then I go over pi over 2 more and go down to negative 1. And then I'm going to finish up where I started, at 0. And we could do this in both directions continuously. Now, for the g over x, it's a bit more challenging, but what we're going to see is that it's going to travel 3 times slower than our unit circle did. So if I look at my values here, when I'm at 0, I'm still at 0, so that's the same. But then the next value I don't get until I get to 3 pi over 2. Now 3 pi over 2 is also equal to 1.5 pi. Okay? So I'm going to get up to 1 at about 1.5 pi. Now I get down to 0 when I get over to 3 pi. Okay? And then when I get to this, which is also the same as 4.5 pi, okay, then I'm going to go over, this is 4, so this would be 4.5 pi. I'm down at negative 1 here. And then I get over to 6 pi, and I get back to 0. So if we draw this curve, we're going to see that it's kind of elongated, or it experiences what is called a horizontal stretch. Now, in this particular case, you can see I'm running out of room on the right. So what I'm going to do is I'm going to travel back one full cycle, one full period. Okay, in this case, my period is 6 pi. That's how long it takes me to travel one full period, from 0 to 6 pi. So I will want to travel back, hopefully you can guess it, to negative 6 pi to start my cycle, because then I will travel through one exact cycle and I'll end up at my starting point. So let's see if that works out okay. So I start at 0, 0. Then I'm going to go over 1.5 pi from there. So 1 and 1/2 pi, and I'll be up at 1. Then I'm going to go over 1.5 more pi, so I'll be here at negative 3, and I'm back at 0. Then I go over another 1.5 pi. So if you notice, all these steps are 1.5 pi. I'm going to be right here at negative 1.5 pi, and then that's supposed to be at negative 1. And then lastly, when I get back and I travel 1.5 pi more, which puts me at 0, I am going to be at 0. So if I connect my dots here, we can see that my curve will connect right where it's supposed to. And so you want to be as neat as possible in these problems, okay? And that is how you would graph the parent function f of x and its transformation g of x.